Hello Squid, Squeeva here with another math tutorial, and in this tutorial I'll be going over integrals. Now I do realize, or I've noticed that calculus in particular comes in very handy when you're doing computer science, especially graphics. So I thought I'd go over a few calculus tricks and tips here, and in this tutorial I'm going to be going over integrals. Now for those who've done calculus before, maybe in your textbook you've seen something that looks kind of like this. This is the integral sign, and it might have a number here, or might have a number here which we're going to represent as b, and a number here which we're going to represent as a, and it has something like x squared d of x. So imagine we have something like that, right? And we want to find the integral. So how would we go about doing this? So first we need to figure out what is an integral, and the integral is basically, so imagine you have a graph like this, and you have the area, or you have a Gaussian distribution that looks like this, right? And you want to find the area under this Gaussian distribution. It doesn't have to be a Gaussian distribution. It could be any curve, so it could be something that looks like this. But we want to find the area under this Gaussian distribution. So we have these marks, these little marky-warkies, and so on, so on, so on. So, and here you say this is 2, or you know what, this is 1, and this is 10. Just for math's sakes. And so we know that we can just add up everything here. We can just add up the lengths and stuff of everything here. But the problem is that we want the smallest amount possible. We want the difference of the smallest amount. So we want something that looks more like this, like something that looks more like this little small space here. So we want the smallest space possible. And this is represented as d of x, the smallest amount possible. Now when you're doing the integral, d of x has no algebraic value. It's just the smallest value. Okay, so this Gaussian distribution is f of x. It's so hard to write with a mouse. That looks at x of plus. It's x of x. That there's f of x. This Gaussian distribution, and we want to find the area under the portion of f of x under there. Okay, so what we can do is we know we have this f of x can either be represented as a summation from 10 and n is equal to 1 f of x, that'll be equal to 1 plus 2 plus, dot, dot, dot. So we could either do that, or what we could, and this is basically just summing up all of this from 1 to 10. So we could do it like that, but that's not quite how we want to do it. We want to get something a bit more precise. So we have, dun, da, 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 an integral. And this goes from 1 to 0, or to 10. I'm sorry. So we can imagine this like a, and this like b, and the integral goes from a to b. Now say f of x is equal to x squared. Just assume this was a quadratic, or something like that. So say f of x was equal to x squared. So up here, we'd have x squared, so it'd be 1. 1 squared is 1. 1 squared is 1, and so forth. And and you don't need to have any really calculus knowledge to know that. That's just basic. That's just basic algebra, because stuff. So if it goes from 1, then that's very inefficient. So we have an integral from 10 to 1, and this is x squared. Now something that's very important, and that'll come in later, is this here is n. This exponent here is known as n. And we have x squared plus, we have x squared d of x. And I'll go into integrals with coefficients a bit later, but basically you have x squared d of x. And this is going to look like, so we can imagine that so we have a little formula here. So the okay. So we know that the integral from a to b is of x to the n d of x is equal to x to the n plus 1 over n plus 1 evaluated to a and b. This is our formula for an integral. Now, we want to find the stuff that goes into the stuff with the stuff and anyways, basically what this means is you want to solve out this equation here from a to b. So this would look something like, in this case, this would look something kind of like 1 cubed over 3 minus, or no, I'm sorry, that's not what it looked like. It goes b, so this here is equal to b to the n plus 1 over n plus 1 minus a to the n plus 1 over n plus 1. So this here would be equal to 10 2 plus 1 over 2 plus 1 Linus, come here. That's my cat. My cat's name is Linus. Linus Pauline, for all those chemists out there who want to know what my cat's name is. So, it's going to be that, and it's basically going to be that minus a. So, I'm just going to assume you know what to put in there now, because, well, we've gone over the equation down here. And basically, you can evaluate that. So, let's quickly clear our board. Okay, so apparently my editor won't let me Control Z anymore, so we can just forget about. Oh. No. So my editor won't let me exit out anymore. So that, and I forgot what it's. Oh, that's right. So down here we can just write 10 cubed over 3 minus 1 over 3, because 1 cubed is 1. So let's just do this real quick. So 10. Hold on. Cubed over 3 is 333.333. 333.333. We can just put a little bar there to represent it goes on forever. Alright! That is basically how you do integrals, so thank you all for watching, and I will see you in the next tutorial.